lesson 3.4, we just talked about this formula, and we talked about it on the previous page too, for the derivative of an inverse. So f inverse derivative is 1 over f prime of f inverse of x. And a key point to remember also is that inverse functions have reciprocal slopes at corresponding points. Okay, so inverse functions have reciprocal slopes. That will be key in this next problem we're getting ready to do. So they ask us to find g prime of negative 1, where g of x is the inverse of f of x. So right there, g of x is the inverse of f of x. That's typical calc, that instead of them using f inverse x notation within something, they just have you use g of x. Okay, so when they're asking for g of x here, they're really asking for f inverse of x. When they ask for g prime of x here, they're really asking for the derivative of f inverse of x. Okay, so just be familiar with that. Now, some information on the chart to fill in. They gave us x and f of x and f prime of x. Now, g of x. What would the ordered pairs for g of x be? Keeping in mind that g of x is another name for f inverse of x.
Just be 5, 2.
Does that make sense? If the x input is 2, the f of x output is 5. So that means for f, the ordered pair would be 2, 5. So for g, the inverse, it would be 5, 2. Okay, let's go ahead and go down that column. When x is 3, negative 1, comma 3. And when x is negative 1, 4, negative 1. Now, g prime of x. So the derivative of g, or the derivative of the inverse.
Well, if the reciprocals, wouldn't it just be 0? Like, because f prime of x is 0.
0, negative 1/4, and
That's
1/6.
I agree with your last two. I don't agree with 0. Okay, so the reciprocal of negative, so we are doing reciprocal slopes here. The reciprocal of negative 4 is going to be negative 1 over 4. The reciprocal of 6 is going to be 1 over 6. The reciprocal of 0 is not 0. What is 0 as a fraction? 0 as a fraction is 0 over 1.
Undefined.
So when you do 1 over 0, that becomes undefined or D&E type answer. Okay, so the idea that 1 over 0 D&E does not exist. Okay? Now, officially, they gave us this big old chart. Officially, the question says find g prime of negative 1. What is the answer to g prime of negative 1? No.
Be negative 1/4. Because the x value is negative 1 on
yeah.
that one.
I was looking at the x value.
Fair enough. That's because it's an inverse, right? Your x and y switch. I feel like they put both of those values there on purpose.
Yeah.
They put the negative 1 in the y slot to begin with
Otherwise-
and the x slot to begin with.
Otherwise, it'd be too simple.
Pretty much.
Yeah.
Okay. So are we good with that? Okay.
I still stand by the statement that they definitely sit there and they're like they just live for like making kids mess up.
Sometimes I can agree with you. Now, okay. The other thought, and I was just debating if I want to take you through the formula real quick, we could use this formula just as well, because if we were asked to find g prime of negative 1, keeping in mind that f inverse is g, so if we use that formula, g prime of negative 1, realize that's going to be 1 over f prime, and instead of f inverse, I'm going to say g of 1. Okay, this formula would work just as well, because it'd be 1 over f prime of, what is g of 1? That's supposed to be a negative 1, isn't it? I'm like, wait, it's like this is not working. What is g of negative 1? And that's 3. And what is f prime of 3? I did something wrong there. Negative 4. Oh, and that's right. And it's 1 over negative 4, because it's 1 over f prime of 3. Does that match my answer? Okay. So, same idea. Okay, shall we talk 4? Notice again, right off the bat, let g be the inverse of f. So they are saying g is f inverse. I think they just do that to simplify the notation. Okay? So let g be the inverse of f. Calculate g prime of negative 9 based on the fact that f of x equals 4x cubed plus 5x. Okay?
Squared plus 5 is f prime of x. F prime of x is 12x squared plus 5. If we plug in the negative 9 from there, and then...
Eventually.
Okay.
Yeah, something like that. I was going to start with, okay, I was going to set up my formula, and then we can...
No.
I'm going to use the formula from above.
Oh.
I
The
was just asking for using the same chart.
No, that chart is dead. How else do I put it? The chart is dead, okay? That was for number 3 only. Okay, so g prime of negative 9, so that's, we're saying what is, really that's asking what is the derivative of f inverse of negative 9, right? That's what they're asking us. So my formula, 1 over, and if you look up above, it's 1 over f prime of f inverse, but I'm not using f inverse. What are we going to use? G of negative 9. Okay? So, 1 over f prime, and what we've got to find right now is g of negative 9. Now, in order to find g of negative 9, I'm trying to think how I want to. Okay, in order to find g of negative 9, that's the inverse, right? So that's us trying to find f inverse of negative 9. Well, if negative 9 is the input on f inverse, what is it on f of x? It's the output. So we want to find when does f of x equal 9. What were we given on f of x? An equation. So 4x cubed plus 5x equals 9.
X equals 1.
And how do you know that?
Because 4 plus 5 equals 9.
Okay. I'm going to call that by inspection. Fair enough?
Gotcha.
This is one, is this an easy one to solve?
Yes.
Well, in terms of a solving method. There's not an easy method to solve this. Okay? However, this is an easy one. Oh, 4 plus 5 is 9. If I make x 1, does that work? It does, okay? And so there's nothing wrong with that. That is a valid method. That's what I would call, you know, we just did that by inspection, just by inspecting it and being smart math people. You know that. And so I'm going to say f of 1 is 9. Now, what does that tell me? If f of 1 is 9, wait a minute. Whoa. Okay. I'm glad I just glanced at the answer key. I've got a huge mistake going. This is a negative 9. That's a negative 9. That's a negative 9. That's a negative 9. That's not a 1.
Negative 1.
But negative 1 makes it.
Make it negative 11.
Negative 4 plus, yeah, it is, because it's not.
Okay, are we good with that?
Yeah.
And that's why I didn't catch it, because in my brain I knew the answer had something to do with 1 in that case. So I'm glad I glanced at my notes. I was like, why does my answer say negative 1 there? Okay, so if f of negative 1 is negative 9, then what do we know? F inverse of negative 9 is negative 1, or what have we been using here? G of negative 9 is negative 1. Did we follow that process? So G of negative 9 is negative 1. And now it's 1 over f prime of negative 1. What do I need to do now?
Plug it, or find the derivative.
What Eli wanted to do earlier, and I said hold that thought, but yes. Okay, so now the other part of this is if f of x is 4x cubed plus 5x, then f prime of x is 12x squared plus 5. And so, excuse me, f prime of negative 1 is 17.
So basically, it could have been positive 1 and the answer wouldn't have changed.
True. We would have never caught our mistake. I unfortunately have to agree with that. So, okay. So we come up with an answer of not 17, but 117. Okay. That formula it's not a formula we use a lot, but it randomly comes up and it's helpful to be familiar with. Fair enough? Okay. Moving on when you guys are ready. Grab your calculator for the next one. Okay. There are questions where you'll need to use a calculator to find approximations accurate to 3 decimal places. Here's an example of such a task. Now, basically, they give you some steps. But basically, we're doing the same thing we just did, except it's not going to be a by inspection type thing. It's going to be a calculator thing, because the inspection is going to fail miserably this time. Okay? How else do I put it? Okay? So, they give us f of x, and they ask us to find f inverse derivative of 3 accurate to 3 decimal places. So keep in mind, this is the same thing as saying g prime of 3. Okay? So, first thing they suggest, they set up the formula in the end, but one of the things we did is, in order to find our f inverse of 3, we had to find when f of x equals 3, yes? Well, if you look at this, we want to know when does 4x to the 7th minus x squared plus x minus 5 equal 3. Okay? With that in mind, check for inspection all you want, but it's not going to get you there. There's a couple different ways you can do this on the calculator. I'm trying to remember. Have you guys ever really used the solver on these calculators?
Couldn't tell you what that is.
Huh?
Couldn't tell you what that is.
Because there's an equation solver, but I'll be honest, I've never really used it much. And
Wish we knew that too.
I'm not always great about using it because I'm not that familiar with it. So I'm going to go a different route. I'm going to go with the let's make a graph. And what I'm going to say when I say let's make a graph is I'm going to graph the left, I'm going to graph the right, and we're going to see where they equal. As in, I'm going to graph y equals 4x to the 7th minus x squared plus x minus 5. And I'm going to graph y equals 3. I'm going to do a zoom 6, because who knows what I graphed last on my calculator. And what do we want to know?
Where they meet
Where they meet. So,
at x equals 1.
it's not x equals 1, though. If you go into your second calc menu, and you use number 5, intersect. We haven't used it a ton, but we've used it a little bit, I think. Intersect. So my first curve is my blue curve. That's okay. I'm just picking my curves. I'm going to hit enter. My second curve is my red curve. That's what I want. I'm going to hit enter. Then it asks me guess. Well, officially guess is just move to the intersection point you're looking for and hit enter. The official intersection point is 1.1063959, comma 3. Okay? So that is the x values there, which is what we're looking for. The 1.1063959 is what my calculator says. It would go on to be more than that. Okay. Now, did you boys both find the intersection point like I just did? Okay. If that's the last thing you found in your calculator, that is saved in your calculator under X. Okay? That is saved in your calculator under X. And so, well, I'll come back and put it on here in a moment. So I'm just going to comment is, this is saved in X now. And that's because we found the intersection point on the calculator. Okay, so officially that was step 1. That value is there. We'll use it in a little bit. Step 2 is differentiate f of x. So this is the other part we're going to have to do is find the derivative. So f of x is that equation up there. Find f prime of x. Should work out to be something like mine. Okay. Now, step 3 officially says evaluate f prime of a at the value from step 1 using all the decimal values, no early rounding. So here's what I'm going to do, guys. I'm going to call this right here. This right here is our a value. Okay? So step 3 says we're going to find f prime of a. In order to do f prime of a, I'm not actually going to type the number in myself because they don't want early rounding. They don't want you, doing anything like that. But what we're going to do, remember I said that's the last value I found? So that value is saved in X on my calculator. So there's a couple of ways we can do this. One, you can just go to your main screen. You can do 28. Now, I'm going to say 28, X, because it's saved in the X value, to the 6th, minus 2X plus 1. I'm going to hope this works.
What
And
gave
it
you
does.
the answer?
Huh?
So what gave you the answers?
Did it give you this answer of 50 point whatever?
146, yeah.
Okay, and it should. And that's based on it plugging in that value of that 1.106 value. The other thing you could have done is we could have done, okay, the derivative of, you could have typed in the original. Ooh, hey, that original was in, what was it, y1, I think? And then I could say when x equals x. And it gave me a slightly different value, but it's still equivalent to 3 decimal places, which is what matters. Okay, so I picked y1 because didn't I type f of x into y1 earlier? So it's still there. X equals x. It's the last thing I found. These regular calculations don't count as finding something for x. Okay. So depending on 50.146, if I look at that first one, it would be 8. Okay. So that was 3. Step 4 basically is now use the formula. Okay. Use the formula of what you're being asked to find. So we're being asked to find the inverse, or g, of 3, correct? Which means our formula says 1 over f prime of g of 3. Or you can say f inverse instead of g if you want. That's the formula. Now, that is 1 over f prime. Well, didn't we find g of 3 earlier? We did. We just don't have it. So right here, when we found this value here, okay, when we found this value here, this is a comma 3, because as when does f equal 3? So now that we flipped it, this is what? So that's in f, it's a comma 3. In g, it's going to be 3 comma a. So g of 3 is that a value from earlier, which that a value is that 1.106 yada yada yada. And 1 over, oops, that's supposed to be f prime of a. Didn't we just find the f prime of a value?
Yep.
That's at 1 over 50.14677 whatever value. And this is, take your calculator and divide it. So 1 divided by, I'm going to go back up and use the original one we got. Either way, you'll get it pretty accurate. 0.01994144624 is what mine is. Now, you'll notice it asks for 3 decimal places. AP Calc rules are 3 decimal places. You go below 3 decimal places, you've just lost a crazy stupid point. Okay? So you want to keep it 3 decimal places or more. Now, those 3 decimal places can be rounded or truncated. Okay, so the idea here, 3 decimal places is that right there. My options for answers include just truncating, so chopping the rest off right there and saying 0.19, or rounding, which what would the 9 tell us to do?
0.020.
Right. So your option choices are 0.019 or 0.020. Okay, that's your official AP Calc choices. Both are correct. So that can be rounded or truncated. Okay? Did you guys write any notes down on step 1 of how we found that value, or do you need to write any notes down? You'll figure it out later if you have to. So, I mean, basically, what do? We graphed y equals 4x to 7 minus x squared plus x minus 5. We graphed y equals 3, and then we used the intersection option. Okay.
So how do I know this when it's going to stop using that as my x value?
When you find another x value. So, I mean, and here's the deal. How often do we push x and use the value solved within x? Rarely. Okay? But so, next time you go and you find a min or a max or a 0 or an intersect point or something like that, then it will just automatically overwrite it and replace it. Okay? Okay. The bottom of this page. I'm not 100% sure why. I guess because exponential functions and logs are inverses. But they throw a few derivative rules in here to memorize. You know, why not? So, we have a few derivative rules, new derivative rules to work on.
We're supposed to memorize that?
To an extent, yeah. Again, it's something that gets easier with use. Okay? I'll be honest. If you want honesty from me, these are the ones I personally am the weakest on. Because you just don't see them that often. Okay? The trigs are more of your better focus. Things like that. So, but the derivative of a to the x. Now keep in mind, a to the x means a is a number. Okay? Other than 1. And then, so the derivative of, so say that's 2 to the x. The derivative of, say, 2 to the x would be a natural log of 2 times 2 to the x. The derivative of a to the u, this would be the idea of when a chain rule comes in place. So it's still the natural log of a, so natural log of 2 times 2 to the u. But then if u is something other than x, you have to do the chain rule and do the derivative of that power. Okay, so this is your basic rule right here. This is what, when you have to do a chain rule. Same thing right here. The derivative, we know the derivative of natural log, and that's always the same base, right? So derivative of natural log is 1 over x. Excuse me. Derivative of log of any other base, log base a of x, is 1 over x, and there's also a natural log of a in there. So it's still 1 over x, but then you have to put in natural log of whatever that base is on the bottom. Again, this over here is just throwing in the chain rule. Okay? Now, let's practice these.
So are 2 and 4 just like, is the u like a y instead of a...
It's ones where you'd have to do a chain rule. So like where, say, the power, instead of being x, the power being x squared. And so then you'd have to do times the derivative of that power.
So what's the difference between number 1 and number 2?
There is no difference. It's just 1 is just assuming the base is just a plain old x, whereas 2, u is something other than x. It's something fancier that you'll have to also take the derivative of. Let's practice these and I'll explain it here in a moment, okay? So a, y equals 3 to the x. They ask us to find the derivative. So I'm just going to use y prime as my notation. What's the derivative of 3 to the x according to our rules? Natural log of 3 times 3 to the x. And here's the deal. The derivative of 3 to some power is natural log of 3 times 3 to some power. If that power is anything that we can take the derivative of, then we'd have to do that. So you could write it as such, or you could also, I have it written in my notes also as an option of 3x natural log of 3. I actually like 3x natural log of 3 better, but they're both okay. That is just following the basic rule 1 there. Okay? B. Y equals 4 to the 3x. Okay. What's the derivative of 4 to some power? It's going to start off the same way it did last time, where you have to do natural log of the base. So natural log of 4, then times a to the power, which is 4 to the 3x. What's the catch this time? Okay, this one we're officially using rule 2 because the u, aka the 3x, can I take the derivative of 3x now? I can. What's the derivative of 3x? That's 3. And that's what that du dx is, because that's saying the derivative of the power. So this one, that's just where we're using rule 2. The derivative of 4 to some power is natural log of 4 times 4 to some power, then times the derivative of the power, and the derivative of 3x is 3. Oh, shoot. I hate when they do that. So, okay. Our answer is going to look different, be equivalent. So if I rewrite this, the 3 can go out front. Again, I can say 3 natural log of 4. And then times 4 to the 3x. Now, this is where I should have looked at my answer key before I started that problem. I forgot a minor detail. Okay, this is an equivalent answer. However, I will say it's not the answer that's showing in my answer key, because what they did is they looked at, okay, is 4, what do I want to say? Is 4 a simplified power? In other words, right now it's 4 raised to the power of 3x. But what do we also know about 4 in terms of powers? So, yeah, 4 to the 3x could also be written as 2 to the second raised to 3x. Is that an equivalent statement?
Yeah.
It is, which means this could become 2 to the power raised to a power 2 to the 6x. Okay. I don't necessarily feel like you have to do that. However, multiple choice, right? And so if we do the derivative on this version, okay, well, it's still going to, if we're use the derivative on this version right here, it's going to be natural log of 2 instead, times 2 to the 6x, and then times, what's the derivative of 6x? And that's 6. Well, 6 natural log of 2 times 2 to the 6x. All of those pieces can be made equivalent to those pieces there. Because a natural log of 4 is 2 to the second, and that power of 2 can come out front and multiply by the 3. 4 to the 3x, well, 4 to the third is 64. 2 to the 6x, 2 to the 6 is 64. So they are both 64 to the x as well. Annoying, but truth.
So, you know, we have 8 minutes left and over 2 pages.
I know. I don't even know what to do about it right now. We've got to understand these rules, though. That's the thing. I can't really skip through these rules because, trust me, I thought about it. Okay, let's keep moving quickly. Y equals 5 to the x squared. Do we know better what we're doing now? This is a to some power, right?
Natural log 5
So natural log of a, so natural log of 5
times
5x squared.
times keep that 5 to that power times the derivative of x squared, which is 2x. Okay? So, where did my x go?
So it'd be 2x natural log 5 times 5 to the x squared.
I probably would. Honestly, this one might even be best left as is. There's not a great way to rewrite it. Okay. How are you feeling about D then? Are we better about D?
Y prime equals natural log of 5 times 5 to the 3 minus x squared power times negative 2x.
Mm-hmm. I'm just going to leave that as is for right now. I'm not even going to waste time. I'm going to put parentheses around the negative 2x just so that doesn't get messed up there. Okay. Keep moving. Next page. The rules are on the previous page, so you're going to have to open your notes so you can look at them. This is y equals log base 5 of x.
So it's just 1 over natural log 5 times x.
Yes. Now, it might be better to write this one as 1 over x, natural log of 5. I'm trying to think how I have that in my notes. Because otherwise, you don't want it to be natural log of 5x. Okay, the x is not part of the natural log. Okay, so that's the basic rule. That's rule 3. Okay, B is going to be the not basic rule. So, 1 over natural log of 3 times sine x times
It'd be cosine x.
cosine x. Now notice that cosine x is not in the denominator, is it?
So you can just put in the top
You can.
cosine x over, and if you want to put the sine x first, we'll put
Yeah, I don't know what I want. I don't like either of them, honestly.
Couldn't it just become cotangent natural log of 3?
Yep, we're going to talk about that next. Okay. This answer is a correct answer. But we've got some ors we can do. A cosine over sine is a cotangent. So we could say cotangent x over natural log of 3.
Wait, it's over? Rather,
It is.
what?
Because cosine over sine is cotangent. So that's like cotangent over 1. And natural log of 3 is in the denominator.
Sine x, I don't know, magically goes to the numerator. Sine x is on the bottom.
But the cosine's on the top.
I know.
And it's, I mean, if you want to think about it, you could think of it as the natural log of 3 is on the bottom, right? So it's 1 over natural log of 3 times cosine over sine is cotangent x. And if it's cotangent x, it has to go to the top. Okay, so he's not going to like the next option I'm going to give. A cotangent on the top is equivalent to a what in the denominator? Tangent. So the other option is to say, or 1 over natural log of 3 times tangent x. They're equivalent. Okay. C. What base is C? It's log base 10.
Yeah.
10 is your default if it's not there. Okay. So, y prime is going to be what?
1 over natural log 10 times 1 with x plus 3 to the x power
Mm-hmm.
times, well, the times in the denominator, but yeah, 1 plus
Okay. 3x.
No, we just learned this rule. This is rule 1 in this group. This is the rule we were just practicing on the previous page.
it's a natural log of 3 times 3 to the x.
Yep. Okay. Now, as you get better about this, Logan, I know you made a comment about, well, it's not in the denominator, it's just off to the side. Exactly. You could go ahead and automatically put it in the numerator. 1 plus natural log of 3 times 3 to the x over natural log of 10 times x plus 3 to the x. Something along those ways. Okay. D. If you need a rewrite to get started, it's y equals log base 2 of 2x plus 1 to the 1/3 power if you need that visual. So, 1 over natural log of 2
times cube root of 2x plus 1.
cube root of 2x plus 1.
And again, in the numerator, what will become b.
The negative 2/3.
Would be, you got the 1/3 out.
Did you put the 1/3 out front?
Yeah.
Okay, so 1/3 times the 2x plus 1 to the negative 2/3 times chain rule, derivative of the inside.
Yeah.
Derivative of 2x plus 1 is
2,
2.
3.
Of course. There's some cleanup you can do here in that the 2 can go on top, the 3 can go on bottom. So 1 over 3 natural log of 2. 2x plus 1 to the negative 2/3 can go down to the bottom. And so we already have a 2x plus 1 to the 1/3. And now a 2x plus 1 to the 2/3 when you move it down below. And that's just going to give you a 2x plus 1 to the 1st, if you didn't see that coming. Where did I didn't write the 2 that I said would be on top. That's a 2 on top.
Yeah.
I said it but didn't write it. So 2 over 3 natural log of 2 parentheses 2x plus 1. Okay. I really hope to get 8 is finding the equation of a tangent line. That's finding the point, finding the slope. 9, I wasn't too really worried about. 10 is using a chart. We've kind of already used a chart, so you guys might be okay on that. Okay. Here's what I'm going to say. Give the homework a try. See what you can do with it. Bring back questions and issues tomorrow. Okay? There might be some where she does an alternate thinking, so I'll have to talk to you guys about mine. So yes, work the homework, see what you can do. I think the ones we are skipping, I mean, it's some of using the chart that we're just not practicing much. So remember that formula. Okay?
Which one?